Yo, lads. Howdy ho, everyone. Let me make sure. Okay. Okay, Discord message sent. Hopefully, you guys can hear me. Hopefully. Is it just. Okay. Just want to make sure you guys can hear me first before getting started because there are a couple of things we need to cover today. Two big ones actually, ARP and ICMP protocols, which would be nice to cover, honestly. Okay. Yo, Rover, what's up? Good morning, boss. Or good afternoon for you. How are you doing, my man? Okay. Can you hear me? Like, my audio is good. Oh, awesome. Dude, I'm so tired today. TGIF, thank God. I have to go over some Docker and containerization and BBX language, this crazy language I have to learn over the weekend, and I'm like not excited at all about that. Not excited at all. Oh yeah, how was the sock? Sock simulator was cool, but I was expecting deeper, more than for speed on the first lesson. Oh, I see. Yeah, I think sock. If you're interested more, right? Um, or practicing. One this technology or this stack called ELK, Elastic Log Stash, and I think Kibana. There is a stack called ELK which is very popular for SOC and SIEM related stuff, and it's I think majority of stuff is. Oh, you did nice because you can download these stuff and you can actually download play around with it and set things up for yourself to play and like learn more about socks and everything. So I believe you can just download like packages, data and stuff, and then that will help you like get get all the stuff. Yeah, there's a lot more practice in the path, just not quite in there yet. Oh, okay, gotcha. Yeah, and there's simple home lab and everything. Nice. ELK is a big one, I know that for sure. And they have like some Slack community for all the people who want to help and everything. Yeah. Okay, I'm waiting. Where's Wrench? Let's ping him. And Sriram, where did you go? Did you did like DHCP? Did you play with the DHCP configuration yet? Went into the router console, played around, changed the IP. We should do that maybe, right? That'll be fun. Okay, I think we can get started a bit with our ARP, bridging layer 3 addressing to layer 2 addressing. You ready? You got your drink? You ready, bro? Let's wrench, my boy. Okay, wrench is also here. Yo, yo. Dose 111. Okay. Yo, 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 yo. Okay. So I think we can get started, right? Like, we'll go over ARP and ICMP today, which would be nice to cover. And do you guys know? Like, I think that would be too much, right? Because asking you guys to come on Saturday evening too for studying would be a lot. Okay. So then, next. So today we will cover task 3 and 4, and on Monday we will cover routing and NAT. Okay. So let's get started with ARP bridging layer 3, addressing to layer 2, right? I was just doing KC7 lab, missed the live stream message. Oh, I see. No problem, man. What is KC7? Oh, it's the cyber detective game. Is it good? Nice. That's interesting. Oh, cool, cool. Oh, you have to use KQL. Nice. Made by Microsoft. That sounds interesting. Okay, it's using ELK. My brain is already there, mate. Don't worry. If it can go more, that would be an interesting thing to see. Okay, so I think we can get started, right? Rover, Wrench, all you guys are here. So let's start with task 3, ARP, bridging layer 3 addressing to layer 2 addressing. We worked yesterday a little bit on the DHCP, talked about how the router gives a private IP to your devices in the house when connecting, right? So now we'll talk about ARP. We have stated that in networking concepts room that has two hosts communicate over a network, an IP packet is encapsulated within a data link frame as it travels over the layer 2, right? We were talking about how, I believe it was, not here. Yeah, here, right? When we were talking about how data link one, the networking layer, right? When it goes to data link layer, another frame, another encapsulation of that packet happens. So that we are going to talk about in this. The IP packet is encapsulated within data link layer over layer 2. Remember that two common data link layers we use are Ethernet and Wi-Fi. So these are the standard names IEEE 802.3 and IEEE 802.11. This you will see a lot actually. These two are you will see instead of like people calling Ethernet or Wi-Fi, you'll see okay this cable is according to this standard. That's all you have to remember because these are the only two you will see. Whenever one host needs to communicate with another host on the same Ethernet or Wi-Fi, it must send the IP packet within a data link layer frame. Although it knows the IP address of the target host, it needs to look up target's MAC address so the proper data link header can be created. What does that mean is, let's say, no, not here, okay. What does that mean? If let's say you are in the house, right? The house router, let's say router is here. Its IP is let's say 1.1.1.1. So anyone on internet, let's say if you're talking to Facebook server, it is going to send data to this IP address. Now the router has got the IP, the packet, but which device out of these three to send it? There's device 1, there's device 2, and there's device 3. Which one to send this to, right? That depends basically on the MAC address, because once the router gets this packet, once the router gets this packet, it has two information. One is the IP information, second is the MAC address. IP belongs to this router, but the MAC address, it belongs to only one of these three devices, and router will look at, okay, which MAC address is this, right? Which out of the three devices has that MAC address, and that device will get the packet, not the other two. It's not going to be broadcasted everywhere. So that's what they are talking about. Although it knows the IP address of the target host, it needs to look up the target's MAC address so proper data link header can be created. As you would remember, a MAC address is a 48-bit number, typically represented in hexadecimal notation in this format, right? 48 bits. First three is for the manufacturer, last three are the unique identifier. These are the two MAC addresses in my network. However, the devices on the same Ethernet network do not need to know each other's MAC address all the time. They only need to know each other's MAC address while communicating. Everything revolves around IP addresses. Consider this scenario. You connect your device to a network, and if the network has a DHCP server, your device is automatically configured to use a... Hold up, what the hell? So many words. So basically, when there are these three, if let's say one wants to talk to 2 or 3, only when it wants to connect, then only it needs to know the MAC address, not all the time. So that's understandable. Everything revolves around IP addresses. Okay. Consider this scenario. Like everything revolves around IP addresses because if it wants to send, it needs to know the MAC address and the IP, because every packet needs this information, right? Consider this scenario. You connect your device to a network, sure, and if the network has a DHCP server like a router, your device is automatically configured to use a specific gateway and DNS server that is inside our router. Consequently, your device knows the IP address of the DNS server to resolve any domain name. Moreover, this part means that our DHCP server, our IP addresses in our DHCP server, DNS server, or our router has all the IPs and list of what they are, who they are, right? So if I want to, let's say I want from my iPhone to reach to my another home like smart watch or something, or even the computer, the iPhone doesn't have to know. It just will send it to the router. Router has a DNS server inside it, and that will do the mapping. Moreover, it knows the IP address of the router when needs to send packets over the internet, which is the main one. This IP address it all needs to know. We need to ban the term smart now, I think. Why is that? Wait, something happened or what? Oh, the smart fridge. Yeah. That's a good call. Who has smart toaster? People are... Okay. I agree. I like that. It's everything is at this point is not... Some Asian company, I'm sure 100%. in all this scenario, no MAC address is revealed. When we are talking through DNS, we want to talk to our fridge, the IoT devices and stuff. No MAC address is revealed. We just need to know the IP, right? Because we just send it to the gateway. However, two devices on the same Ethernet cannot communicate without knowing each other's MAC address. So instead of just me sending to Facebook, in this case, I want to send from device 1 here to device 2. Then I need to know the MAC address. Then I need the MAC address. So outside you need the IP, inside network you need the MAC address. As a reminder, because if you are confused, right, let me just go over quickly. I'll tell you why. Okay, so let's say device 1, right, wants to talk to device 2. Where is Panda? Oh no, Panda is probably working. I know, like Panda never hardly shows up in the morning ones. It's only the evening ones. So yeah. So yeah, maybe. Did he say anything in the what's it called? Discord? Okay, so as I was saying, right, let's say device 1 inside the house wants to talk to Facebook, right? It needs to know the IP address because outside it needs to know the IP. But inside is different because for IP, it knows the IP of the router. What router knows is the MAC addresses of all of them. MAC addresses of all these 3 devices, it knows. So when the device 1 wants to talk to, let's say, device 2 or 3, it needs to know the MAC address so it can tell the router, hey, first it sends the packet goes to the router. So device 1 sends packet to the router. How? Using the IP address, right? The key information for communication would be IP. Now router looks up for device, let's say it wants to connect to device 2. So for device 2, it will look up at its MAC address. It will tell the device 1, this is the MAC address, like A, B, C, D, E, F. So let's say this is the MAC address. So now for device 1, we'll always send with the information of IP of the router, basically. It needs to send IP and MAC, right? It will send that MAC in its packets, basically. As a reminder, in the screenshot below, we see an IP packet within an Ethernet frame. The Ethernet frame header contains destination MAC address, source MAC address, and IPv4 in this case. And let's quickly look in one thing. If one device wants to talk to another device in same network, what IP and MAC is used in the packets? Let's see. When two devices on the same network, destination IP address of the target device and the destination MAC. So we have computer A, Ethernet frame packet. Let's see. When devices on the same network, they use the destination IP address within the packet's IP address and the router's IP address if they're leaving. Okay. Okay, so got it. So instead of just the MAC here, let me just remove this. Say device 1 talks to router, right, and says what is the IP and the MAC of device 2, right? Router will send back the device 1 IP and the MAC address of the of the device 2, right? And then packet 1 will send things. Router will be used in the as a communication, but it will be sent to device 2 directly after that with the IP and MAC. And device 2 will directly send to the device 1 because this packet will contain device 1's IP and MAC as well. So that's the proper communication. Okay, beautiful. That's the only confusion I was getting. So as a reminder, in the scenario below, we have an IP packet within Ethernet frame. The Ethernet frame header contains destination MAC, source MAC, and type IPv4. So this is the MAC address, these two. And IPv4 is mentioned. Let's see the IP. So source IP, destination IP is also mentioned. Source IP, destination IP, source MAC, destination MAC. Address resolution protocol makes it possible to find MAC address of another device on the Ethernet. In the example below, a host with the IP address this wants to communicate with another system with the IP address of this. Okay. It sends an ARP request asking the host with the IP address to respond. Okay. So I have for device 1 as this, device 2 is this, and it sends the ARP request. ARP request is like, a flood gateway. You just send a request to all the people, or basically you can send to a particular one, but a lot of there will be times when you just send an ARP request to every single device in your network. I do that. Whenever I'm setting up Raspberry Pis in the house, I need to do that. It sends a ARP request asking the host within the IP address of this to respond. The ARP request is sent from MAC address of the requester to the broadcast MAC address, this one, as shown in the first packet. The ARP reply arrived shortly after, and the host with the IP this responds with its MAC address. For this point, the two hosts can exchange the frames, right? So what here is happening, let's say we again go back to 1, 2, and 3, right? Let's say 1 wants to know the MAC now of 3. Another way for this is using ARP, they are mentioned. 1 wants to know, let's say whatever the IP of, let's say the IP of 3 is IP3, like if this is the value, right? Device 1 sends device 3 and the packet will have info as IP3, and another information it will have is for MAC address broadcast MAC address, right? Broadcast MAC, which is F. All the 8 things are just F. The third device will now respond to the first one with its IP of 1 as the destination, and it in the packet, in the information, it will also have its own IP. This will have MAC of the first device as well as MAC of the third device. That's how this is saying. If we read again, right? Example below, host with IP, let's say IP1, wants to communicate with another system with IP3. It sends an ARP request asking the host with the IP address to respond back to IP with the IP address of this. So this is our IP3 to respond me and give me the MAC address. The ARP request is sent from the MAC address of the requester to the broadcast MAC address. Just like when we are want to talk to the router for the first time, it sends to the broadcast IP, which is 255.255.255.255. Same thing it does for the MAC address. It goes to the FFF, the very last possible MAC address, as shown in the first packet. The ARP reply arrived shortly after with its IP as well as the MAC address. So if you see T-Shark ARP, right? We are looking at the PCAP package or the file. At time 0, device 1 with the MAC address of this sends a ARP request to the broadcast, right? And these are the IP addresses. Who has this IP? Tell to this one, right? This is our IP1. This is our IP3. The IP3 responds at 0.003 seconds saying, hey, this is my MAC address, sending it to this MAC address. See, this is same as the IP MAC of 1. IP3 is at this MAC address. Simple communication, as I said here as well. The first device asks who has this IP and the broadcast MAC address is sent. Third responds to first device saying with the IP and MAC. If we use TCP dump, the packet will be displayed differently. It uses the terms ARP request and ARP reply. For more information, output is shown below. So it's just based here we are using the PCAP, right? Here we will be using TCP. We are using T-Shark command as well, TCP, and things are same basically. An ARP request or ARP reply is not encapsulated within a UDP or even an IP packet. It is encapsulated directly within the Ethernet frame, which is important. The following ARP reply is shown. So we have address resolution protocol, our ARP reply, the hardware protocol, blah blah blah, but important information is here. Server MAC address, server IP address, target MAC address, target IP address. ARP is considered layer 2 because it deals with MAC addresses. Others would argue that that it is part of layer 3 because it supports IP operations. What is essential to know is that ARP allows the translation from layer 3 to layer 2 addressing. Basically, what you need to know is ARP and MAC addresses are used because, or basically with the ARP, it wants to connect the IP to a MAC address. Why it is important? For communication, right? With just IP you can't, right? You need to know the MAC address as well. Because internally there is no, like things change, the IP changes, right? But MAC address remains same, it's hard coded on your device. So it's important to know the MAC address of the server, of the IoT device, of the watch, phone, whatever you want to talk to. And I will say ARP, people can talk about like layer 3, layer 2. In real world, it doesn't matter what you feel like which layer or layer 2 or layer 3 it belongs to, because at the end you need to learn about the functionalities to be in cybersecurity or even in like tech. Important to understand the functionalities, that hey, I can use ARP to find all the devices connected to the router, and then I can tell based on the MAC which IP belongs to what device. It can be an Apple device, it can be a Samsung, it can be a ARM, whatever it is. So I'll do these ones today. What is the destination MAC address in an ARP request? So request, when you're requesting, yeah, yeah. So when you're requesting ARP, right, it's same as the IP, broadcast IP, right? This one is the broadcast MAC address, and it all has to be the very end one. Unauthorized? Oh, I need to do a quick refresh, probably. Okay, great. Need to log in. Amazing. I joined the room. Yeah, okay. So after that hiccup, let's go back. So we were talking about the broadcast MAC. Broadcast one is a special one. It's always the very end one. Whether it's the MAC address or the IP, it's always the end one. In the example below, what is the MAC address of this? 192.168.66.1. Let's see. Reply from this is at this MAC address. Alrighty. Dude, I'm actually tired today. Do you want to do this one like on Monday? Because I'm a bit tired right now. 1 second. I got a message from TikTok HR, says data analysis indicates that your work habits are perfect to work at TikTok. So fuck TikTok first of all. So TikTok recruitment, they're a perfect match for TikTok recruitment. If you would like to talk, here's the WhatsApp. Do you want me to send? Okay, but do you want me to send the phone number they contacted me through? You want to have fun with them? Okay, I'm just sending, so just enjoy. Here it is. I'm sending in Discord. Let's see. What is that? Oh, Panda is here. One second, lads. 1 second. 1 second. Here we go. Enjoy. Enjoy, lads. Have some happy hacking. Merry Christmas. Dude, like the amount, you only need to work 60 to 90 minutes of work per day, and you can earn up from 200 to 1500 cat. What do I have to do? Go against Canada? Like, what the hell? It's crazy. Okay, how big is the ICMP? Ping is there. Trace route is there. Okay, we'll just complete this one too. Fuck it. Let's just complete this one. Let me drink some quick water. We'll complete this because this is not that long and I don't want to leave it for Monday specifically. Monday mornings I'm already not happy that it's so far away from Sunday. Okay. ICMP troubleshooting networks. ICMP troubleshooting networks. The protocols that are using this, the commands that are using this protocol are useful in finding if you are able to connect to the internet properly. What are the issues? That's why it says troubleshooting networks. Internet Control Message Protocol (ICMP) is mainly used for networking diagnostics or error reporting. Two popular commands rely on ICMP and they are instrumental in network troubleshooting and network security. The commands are ping and traceroute, right? First, in ping, I think majority of the people have seen it. If not, today is the day. It's a great day then. Ping, this command uses ICMP to test the connectivity to a target system and measures the round trip time, right? So ping basically, let's say, when you are if you're in some websites, right, things are not working. What you do is basically you go on Google and check, hey, am I able to reach google.com? Ping is like that exact mindset. When you want to reach or want to see if you're able to reach something, you can turn on your command prompt and ping, let's say, an IP address or even the DNS URL, right? For example, google.com. You can do ping space google.com, and if it comes back with like packet received and stuff, right, you can see that, okay, at least the internet I'm able to send is might be a issue with the browser or some other way. But if ping is not there, then you can't reach internet. So this command uses ICMP to test connectivity, right? Internet connectivity or network connectivity to the system we want to talk, right? Round trip time is useful to see what is taking so much time and things. Interestingly, this round trip time, if you think this is not that useful, when the backdoor, the XZ backdoor, the big one in Linux itself came out, was actually started with the fact that the round trip was taking a little bit extra than usual. That's how things work with the PostgreSQL engineers saw that. So in other words, it can be used to learn that the target is alive, right? Or you're able to reach, or the target system itself is alive, and that its reply can reach our system. Next is the traceroute. This command is called traceroute on Linux and Unix system, and tracecert on Microsoft Windows system, of course. It uses ICMP to discover the route from your host to the target. So, you may have never played ping pong, table tennis, before. However, thanks to the ICMP, you can now play it with the computer. The ping command sends an ICMP echo request. Echo is basically, when you go to the mountains, you say something, you hear it back. Same thing. So it's echo request type 8. I have no idea what that means. The screenshot below shows ICMP message with the packet. So, type 8 like the echo ping request. So source is this. I want to reach this one. And what did I use? I used ICMP protocol with the ping command. Ping is type 8 itself, to see if I'm able to reach there or not. The computer on the receiving end responds with the ICMP echo reply type 0. They have their own code words going on. See, first the source and destination changed, right? And there is the echo reply. First one was the request with 8, reply is with 0. Many things might prevent us from getting a reply. In addition to possibility of target system being offline or shut down, a firewall, which is a lot more common nowadays, a firewall along the path might block the necessary packets for ping to work, because a lot of these firewalls block the ICMP protocol. In the example below, we use -c, right, for flag and 4 as the value to tell ping commands to stop after sending 4 packets. If I'm able to reach once, I try again, right? I'm able to reach, let's say, 2 or 3 or 4 times. I don't have to keep on going and checking if I'm able to reach. When you go on google.com to check your network connectivity, you refresh once or twice, but you don't keep on refreshing for minutes to check, right, if it is working. So that's what it is. Ping, you type the IP address what you want, right, the destination. -c4 is like, hey, send 4 packets only. And at the end it sends 4 packets. 4 are received, 0% package loss. If there is like the internet or like the system is shut down, it's not able to reach some reason, there would be a percentage, let's say 100% package loss, right, and 0 received. The output shows no packet loss. Moreover, it calculates the minimum, average, maximum, and standard deviation of the round trip. What you need to know, actually, not even the minimum. I will say look at the maximum. Okay, this is taking a lot, some of them, right? So have a look what could be the reason with such a big deviation. A lot of people do look at that, right? For a cloud company, they need to know. A data center company need to know. For you, it might not be that big. Next protocol is traceroute. How can we make every router between our system and a target system reveal itself, right? We did talked about here. If we go, I think there was an image we used. Okay, here's the image. Hops like a bunny. Yes, sir. That's actually true. It does. Exactly does that. Okay. So let's say this is you here. This is you. Right? This is YouTube. Sent you an exact fix for this on Discord private chat. Okay, sounds good. Thank you, bro. Okay, sounds good. Thank you. So there is you, and this is the Twitch or YouTube server, right? Your data might be going like this. First onto this router, right? Then this router, then this router, then the server itself. Now, if you want to see, okay, what is the IP of this, or what information about this, and this router, that's what traceroute can help you, right? How can we make every trace router between our system, or every router between our system and target system, like the server of YouTube or Twitch, reveal itself? The internet protocol has a field called time to live, TTL, that indicates the maximum number of routers a packet can travel through before it is dropped. So how many times it can hop, how many seconds it can do. The -v of IP? -v, oh maybe, I don't know about IP dash. What is the -v? Which command you're talking about? Like, the -v. Okay, let me check. Oh, it's the verbose mode. Yes. Kind of. Yes. Like it's more like a verbose mode of the ping. It does though. It is similar to that what you are saying. No, the IP is not a thing, but it is for the ping. It is the verbose mode of the ping, not the IP. Yes, dude, you have to tell me. Sometimes I do get questioned. I question myself. So I was like, is there an IP command? I don't think so. The router decrements the packet's time to live by one. So there is something called time to live for every packet, right? That indicates the maximum number of routers a packet can travel through before it is dropped. Maximum number of routers. So it's not in seconds they are saying. It's maximum amount of hops from one server, one router to another it can reach. Yep, it is. It is toasted. The router decrements the packet's TTL by 1 before it sends it across. So, in our case, when you are sending the packet, let's say its time to live was 2, right? I'll go here to, let's say its time to live was 2. It reaches here, now the packet's time to live is 1. It reaches here, now it's 0. So it will never reach to its server. It will, let's say you send 5, some just above the one you need to reach, goes 4, 3, 2, 1. Right? You still had one more, just in case one router was not working. Okay. Have you seen so much better now? So much better now. These 3, 4 I can't do anything because I have to check, but so much better. When the TTL reaches 0, the router drops the packet and sends the ICMP time exceeded message type 11. In this context, manageable with meds. Holy. In this context, right? Time is measured in the number of routers, not seconds. So, number of hops it can do. The way you were saying, Rover. The terminal output below shows the results of running traceroute to discover the routers between our system and example.com. Some routers don't respond, and in other words, they drop the packet without sending an ICMP message. So, certain routers have this security firewall. If you're asking for this trace route, they will either drop the packet or they will not give you any information. They will say no, nothing, blank. And some do. Routers that belong to our ISP might respond, revealing their private IP address. Moreover, some routers respond and show their public IP address, and this would let us look up their domain name and discover their geographical location. Finally, there is always a possibility that an ICMP time exceed message gets blocked and never reaches us. So if you see here, with traceroute to example.com, 30 hops maximum, and it's a 60 byte packet, right? Let me copy the whole thing so it's easy to see in one go. Oh wait, actually I have this guy. How can I make it? I don't like the fact it's all. One second, lads. Nope, fucked it up more. Okay, I'll just do this one for now. I want to just make it look good. I don't like the fact that it's so ugly looking right now. So out of order. 1 second, give me 1 second. Okay. Okay. Better. Better. Okay. I don't know where is 10. 10 and 12. That didn't get copied. Okay. Now let's do this. So we sent a trace route to example.com. I should like change that. Like I should not look into Auxiliary so much. Yeah. It's just I'm able to draw. That's what I like about this too. Okay. We have trace route to example.com and bro, I have okay, sounds good, boss. Thank you for joining. I'll see you tomorrow. 100%, 100%. Screen grab and move to draw maybe. Yeah. I should need to yeah. All good, all good. I'll see you tomorrow, bro. Don't worry. We are almost done here too, right? We have 30 hops maximum, right? From the gateway, so this is our right stuff. We go to the router, and then we have another router which go from this router to this one, and these are all the this one. I'm not sure if this is maybe this is a public one. This is a private IP address. Then we have routers that don't want to reveal any information, right? No info. They say we are not giving you any info, which they can do. Then we have another one, 172, which is again a private IP address. Then we have this one, IP address with a domain name to it. So if I go on my Google Chrome and I type this domain name, I will be reaching this server, right? Next is this guy. Oh, this is, yeah, next is this one. The another server with the name itself. With the name here, with the domain name. And it's entity level 3. Entity is a company, if you don't know, which is also a networking company. Same entity again. And it's actually such a big company when it comes to internet. I think it does like a takes care of a bunch of domains too. Like those www things, it take care of those. Then we have another entity one, another entity. Now again entity, right? All these servers. Now we have a CDN one, which is could be like from Amazon or something, right? The CDN is content delivery network to make your website come closer to your let's say if I made a website and I have a bunch of folks or users in India, I'll make my website go closer to India, right? Majority of the stuff I want to store so it's faster will be in India. How will I do it? With CDN network, CDN servers. And this is a CDN router. And then it goes here at the end. So just an interesting way to see what's going on in the world. The traverse route might change as we rerun the command. So router sometimes from one router it can go like this. That's why there was an average and all those, right? There was average, there was this, because if let's say we are here, next time I ran, right? Next time I ran this command from me here. Next time I ran this command, instead of going from first it goes here, blue. No. Red. First it goes here, right? Instead of here, it goes to this one, let's say. Then it reaches here. Then here. This time, the time will take more, and that's why with the with the ping command, there is average, there is min, there is max, all those information, because routers can change. You see min, average, max, and standard deviation. So yeah, that was the two big ones, ping and trace route, to help with your network connection. Using the example images above, how many bytes were sent in the ping request? How many bytes? A single one. We sent four of these, right? And bytes 56. Why there's 84 in the bracket? Need to look. But 56. Come on. No? 84? The data field is often used to indicate the size of the request. $60 packet, but in the ping command, oh, 64, yeah. 64 bytes. No? What is the answer for this one then? If it's saying 64 is not. Here, this example? 98 bytes captured. Okay. They don't even tell which. Oh, in the images, okay, 98. 98. I'm so baffled. 98 bytes on wire, 98 bytes captured, ping, blah, blah, blah. Oh, 40. 40, 40. Yeah, yep. It should be 40. There's so many data points of like, oh, this byte, this byte, this byte. Which IP header field does the traceroute command require to become 0? Which traceroute field? Hops, max. Hop? No. Which IP header field? Which IP header field? Oh, TTL, yes. Yes, yes, yes. My brain, man. Thank you so much, Robert. Thank you, thank you, thank you. Bro, I can't think straight today. I need a weekend off. I've been, even on the weekend, last weekend, I was just studying Adobe AEM, and I feel like the effects now. One day I will be a proper streamer, and I'm just streaming, so my brain works 24/7, or every time at least I stream. Dude, I want to, man. I want to. It's just right now the market and how things are going in my company, it is like kind of rough. So I hope really like soon I find that time. Soon I find that time. I really hope. Yeah, that's all. But we'll find time. I'm also like I need to be more efficient, and if I'm more efficient, I probably can find more time, right? But yo, we'll watch the yes theory tomorrow. We'll watch the yes theory video tomorrow. Okay? I want to watch that next one which you sent, where they like give him like I think 100,000 to pay off all the debt, or like take him for a yacht vacation, his dream vacation. I want to watch that. You will? Are you free tomorrow, like Saturday evening? Okay, yeah. I think it was the 100,000 debt they paid off. What do you think? Like, will you be free though? That's the main one. Okay, I'll post in the what's this called Discord. We can chat there then. Okay, it'll be fun. We'll do that. We'll do that. Yeah, 100%, 100%. We'll do that, and I will send it properly so timings match for everyone. Yeah. Alrighty. Yeah, this was it for today, or at least for now, because today I'm coming again for the lead code one, which has been fun. But yeah, thank you so much, everyone, especially Rover, Wrench. You guys were amazing. Thank you for all the chats. And I will see you guys in the evening for some lead code problems. Till then, this has been your favorite neighborhood hacker, the sniffer of packets, censored hacker, signing off with a big bye. Thank you so much. Thanks, Robert. Love you, bro. Thank you.